without further ado, let's go to Omar Sheikh of the Austin Company. And Omar is going to present on BIM, or also known as Building Information Modeling Metrics. Take it away.
Thank you, Paul.
Putting your presentation up. There you go.
Hello, everyone, and welcome to the final presentation of Track 1 on Day 2 of the Innovation Day Symposium. My name is Omar Sheikh, and I serve as the Manager of Structural Engineering of Western Operations with the Austin Company. Today, I would like to present to you a method of leveraging our BIM, or Building Information Models, to not only extrapolate powerful quantities and cost data for our projects, but also to add incredible depth to our business experience. I refer to this unique method as BIM Metrics, and any one of us who interacts with BIM, such as with Revit files, has the ability to exploit this powerful process. As we embark on this journey to explore BIM Metrics, let's chart the path ahead. We will start with an overview of overriding concepts. Next, let's explore the logistics of the BIM Metrics method. Then, let's overview the product of this method. What exactly is produced? We will then review the numerous advantages of this method. Finally, we will assess an example of how this method was put into action just over the past year to augment our business. Any one of us should be able to relate to the dilemma of the estimator. When a project is estimated, the estimate needs to be provided quickly, and it needs to be accurate. The estimate also needs to occur amidst an environment of evolving scope, as well as multiple stages of the project, from concept to construction. In our industry, we're all familiar with the types of questions related to quantities and cost, which arise time and again. How much steel tonnage does this project have? How about linear feet of HVAC duct? What about total square feet of gypsum board? A deeper probing question may be, what is the cost per square foot of a concrete pile foundation system for the southeastern United States region in 2023? The answers to these questions, and many more like them, can be rapidly and precisely answered at all phases of a project. Furthermore, the responsibility of being able to answer these questions should be incumbent upon every member of the design-build team. The reality of our industry is that we are all estimators. If you are a design engineer, the cost of the project lies within your designs. If you're in pre-construction and construction, then you make the estimate real. As design builders, we must therefore understand project cost at every single stage. Nothing we do can be separated from cost consideration. So, how do we achieve robust estimating in our projects in the world of big data? The BIM models we possess, the Revit files we work on day after day, are a goldmine of data beneath our feet. The big data sits idle, waiting to be harvested and interpreted. As BIM becomes continuous in our workflows, from the proposal stage to design to construction, the power of continuous BIM metrics estimating is on standby, waiting to be tapped. Indeed, in the rapid and evolving conditions of any of our projects, being able to provide accurate price estimates on demand will allow our businesses to flourish in both the immediate and long-term timeframes. So what exactly are the steps of the BIM Metrics method? The process is technical and computer-based. However, it can be distilled into 4 primary steps. First, the design-build team must identify what needs to be quantified. Second, the BIM model itself must be properly organized as the model is generated and developed. Third, a system of tools must be put into place to harvest the data from the BIM model. Finally, the crop of information must be studied and interpreted by the design build team. Let's dive deeper into each step. For the first step, the principal question is, what should be measured? What information in the virtual BIM file do we wish to quantify? For a structural engineer, for example, the wish list will include steel tons and concrete volumes in yards. For a mechanical engineer, the focus will be on duct and pipe linear feet, among others. Each design build team member will champion different aspects of the virtual model, which should be measured. Note that programs such as Revit have auto-labeling schemes to identify general components, such as columns, beams, and walls. These are standard identification categories offered out of the box. You will often find, however, that what you are interested in measuring is requiring a custom identification scheme, which goes beyond the standard bins. Step 2 deals with the all-important organization of the BIM file. Imagine a library of books without any identification labels. Think of the chaos and inefficiency which would ensue when you need to find a book out of a shelf with thousands of options. Proper organization makes placement and retrieval of big data possible. So the team must establish a protocol of how elements are to be labeled. The organization and labeling process is followed in real time as the model is being developed to make easy retrieval of information possible later on. The BIM file organization scheme will also include setting up of schedules and views, which are ready to be populated with data as the model progresses. Once the virtual model is generated and organized, the precious data which it contains can be harvested. In Revit, once a modeled element is properly labeled, it is automatically sorted within tables or schedules. These schedules can then be harvested as standalone files exported from Revit. Note that with the use of software such as Clarity, auto extraction of data can be scheduled monthly, weekly, or even daily. Finally, custom computer scripts can be written in languages such as Visual Basic and PHP plus MySQL to organize and place the harvested data into external databases. So we have a mountain of data. Now what? The last step of the BIM metrics method, where we interpret the crop of data, is where the proverbial rubber meets the road. This step will involve the use of custom computer scripts to efficiently parse through and render the harvest. The data we extract from the Revit files is not best exploited with simple spreadsheets. We must create custom computer programs to parse, analyze, and manipulate the data quickly and exactly how we want. We have generated such a program. So what are the capabilities of this custom scripting? Here are a few of its applications. In building a robust estimate, we need to be cognizant of the fact that not everything is included in the virtual model. What are the gaps of scope in this data, such as connection plates, rebar, and other items that are not typically modeled? Our custom script assigns allotments for such gaps so that predictions are comprehensive. We must derive patterns from the data, which makes sense to us. We need to develop rules of thumb and ratios that we humans can remember. For example, if we have a list of steel shapes and weights for a building of 100,000 square feet, maybe we render all of this data into a single number we can remember, the total pounds of steel per square foot. Such a ratio will be much easier to remember and use as a comparison point with other buildings. The custom script sorts through the raw data through mathematical algorithms to produce succinct ratios from each harvest. We must also log the results of our harvests over time so that we have a history of results we can study. The custom script renders chronological data points graphically in charts. Finally, the script couples the quantities data from our harvest with price assumptions so that we reach our ultimate goal. Indeed, the materials data we have harvested, when viewed together with an assumption of price per unit, will yield a complete estimate which we seek. Now, it's important to note that unlike the static nature of the materials data which we have harvested, the price assumptions which we assume are dynamic and changing. Factors such as geographical region, economic climate, and material worth will all dictate which batch of price assumptions are right for a particular project. The team should leverage experienced estimators, price databases such as RS Means, and subcontractor contacts to obtain reliable price assumptions. The product of the BIM metrics method must at once provide comprehensive data and also be succinct and user-friendly. The primary deliverable of the BIM metrics method we employ is an accessible PDF which can be easily distributed and shared. It is visual with judiciously chosen 3D views to augment understanding of tabular data. The tables and visuals are also easy to read and utilize. Take this example sheet of a Revit BIM Metrics package for a recent project. This sheet focuses on a steel platform which was part of that project scope. Now, this sheet is filled to the brim with information which is a goldmine for anyone wanting to derive an estimate for the project. There's a 3D image, an indication of the material, which in this case is steel. A splitting of the elements of the platform, which were carefully organized by the BIM team during modeling, in this case as beam framing, columns, and grading. There's a line item of totals, a title block indicating project info, and finally, a summary of price per unit assumptions, as well as line item estimated prices. Note that this sheet was not laboriously manually created. This sheet was auto-populated with information. Once the initial work of setting up the BIM metrics template was complete, of which this sheet is a part, the sheet was ready for all subsequent prints. The team simply needs to review it prior to that print. Of course, the other salient deliverable from the BIM metrics process are the actual data files. For team members who want to manipulate the data with their own custom methods, like Excel, such files are very useful. The BIM metrics custom scripting also generates an at-a-glance summary sheet as part of the package. This sheet contains critical major data points that the team should consider. For example, like the total estimated price for a given material. The BIM metrics package also includes time history charts of quantities and price estimates, which have been auto-generated by the custom script algorithm. All measurements to date are stitched together in chronological order in these charts to view insightful time evolution. Ultimately, if we can summarize all these deliverable components into one phrase, the BIM metrics method produces an accurate materials and price estimate. The BIM metrics process is a game changer. It allows for powerful short-term knowledge as well as deep long-term insight. We can ascertain useful ratios and rules of thumb for projects. For example, we may ask, what is the expected concrete volume per square foot of a building area for a food manufacturing facility in the northeastern United States? If you have done anything similar to this project in BIM in the past, then BIM metrics can give you an answer to such a specific question. And this answer will be continually sharpened as you gain more experience and data points from subsequent projects. We can enlighten the design build team with in a nutshell data. Seasoned professionals and junior team members alike will be able to take away the crucial data for any project. They will understand the big picture and remember these useful ratios for the next project. The BIM metrics process is almost completely automated. It exploits an initial setup effort, the speed of computer software, and the power of custom scripting to achieve the holy grail of precision coupled with speed. The harvested data can be organized into a company database so that quantities and materials historical data can be revisited and absorbed by the team. With easily digestible rules of thumb and ratios, we can guide the design build process. You can immediately identify in the design phase if the project price is too high or too low. More specifically, you can pinpoint which bins of elements are responsible for the anomaly. Finally, the ratios themselves serve as targets. Can we do better? Why can't the ratio be more economical? We can quantify the optimization of our designs. When we view a series of BIM metrics results together over time, insightful charts emerge. These time history charts show the price evolution of the project. What is the story behind these charts? What design refinement, value engineering, and change occurred to dictate the movements that we see in the graphs? The time history chart renders a holistic view of project quantities and prices. Not only do we see the quantity and price of general categories, such as steel, concrete, stud walls, and piping, we can see further sub-distributions. For the material steel, for example, we can view line item data for steel beams, steel columns, and steel braces, among as many other bins as we define. Once we have the stratification, we can see the line item cost of each subsystem and see how it contributes to the price of the general category or material. Patterns emerge, which are useful in pinpointing project streamlining efforts. Take, for example, the general category of steel for industrial buildings. The columns of such steel buildings often comprise a chunk of 25 to 35% of total steel tonnage. So this sub-bin is a prime target for design streamlining. If the project was modeled in Revit or a comparable BIM software, then data can be harvested from it. With minimal effort, a long-forgotten Revit model can be harvested of the quantities data gold, which we all seek. Just over the past year, our team has harvested data from over 15 past Revit models to glean critical patterns for our typical project types. There is no reason we should leave any of our existing BIM files untapped. How many models do you have that can be harvested and added to our knowledge depth? Now let's take a look at the BIM metrics process in action. The data you see on the screen, a measure of the steel tonnage ratio for a new building, was generated by our custom script just over the past year for a real project. You will note that the BIM model was harvested often over the design phase of the project. In this case, we have 5 data points over time. The project started with a conservative tonnage in the preliminary phase, when the scope was still malleable and evolving. The team actively flagged this early tonnage as conservative and needing reduction. As the design continued to refine into later phases, the design tonnage settled well within a range that is typical for similar building types. This graph was instrumental in being able to step back and look at the project as a whole and flag where the design steel tonnage was undesirable. This graph allowed us to surgically reach the project budget goals over time. As this same project was put onto the street for bidding at numerous points, the materials price estimates were also monitored. This chart, which you see on the screen, depicts the high and low price estimates which the BIM Metrics algorithm predicted for total steel on the project. Both in early phases, as well as the final design phase, the bids received from the subcontractors fell beautifully within the price band predicted by the script algorithm. This case study project also highlights another corollary advantage of BIM metrics, which is that computer modeling issues are highlighted and more easily identified. Look at this chart, for example. The early phase concrete volume data indicates a yardage, which is astronomical and far above what is to be expected. After a further assessment of this anomaly from the harvested data, it was found that numerous concrete elements had been incorrectly labeled in the Revit file. Once identified, of course, the error was quickly fixed. The reality is that mistakes in our virtual models will happen, and the BIM metrics process actually serves as another quality check to add to our arsenal. The Kajima family of companies prides itself with a strong design build legacy. As such, the design, pre-construction, and construction processes must be fully integrated. Even at the conceptual stage, we must confront materials and cost. We must always have the project budget in clear view as designs are assessed and refined. The BIM metrics method allows us to thrive in the world of big data and ultra-fast computing. It allows us to be true design builders in this new landscape. In any one of our companies, we likely have a trove of tens to hundreds of Revit files over the past 10 years, some currently active and most others archived. What have we learned from these projects? What patterns can we quantify from this vast experience? Have we inputted this knowledge into a database? I urge all of you to utilize the BIM metrics process to learn deeply from our past and to make accurate predictions for the future. Thank you.
Thank you, Omar. And you know, that's the point you make about data and old data that we have.
Right.
We all have terabytes of data stored in our servers of projects, various items, various things, which may or may not be useful to us. But when it comes to design and design build work, there are certain rules of thumb that we can use, and I think it's a really good point. And running it through these algorithms to filter out and make use of it and get us in the right realm makes a lot of sense.
Yes, absolutely. I mean, there's, I mean, as you bring up, I mean, we just have so much data beneath our feet, and the cost of harvesting it is so small that why wouldn't we want to learn to see what those old projects hold? When we went on this journey of looking at previous projects that we had in our arsenal, we actually found some intriguing patterns that we were able to utilize to predict current projects and ones into the future. So we never know what's lying beneath our feet until we explore it. And again, the cost of doing so is small. There's not much work required to get useful parameters out of existing models.
Yeah, we often get, you know, really just sketches from an owner that are very, very conceptual. And it's like, well, how much is this worth? And so we can apply various rules of thumb, various metrics, but the idea of being able to say, hey, you know, there's this much concrete, this much steel generally for this type, it's this square footage. So that would give us, if we had that data at our fingertips and we say, well, you should assume this many pounds per square foot, it would help those of us that frankly don't try and remember all this stuff in our head like a computer, because that's what we have computers for. But also people with less experience, it gives them something to base things on and collaborate on those, those answers for owners.
Well, that's such a salient point that you just brought up, which is that, these numbers that we talk about, these in a nutshell numbers, this is really what people can take away from this in the long term. A lot of people, they're not going to memorize or remember the specifics of the tabular data, or even the details perhaps, but they may remember something like, hey, if you have an industrial steel building, that is in a high seismic zone or high wind zone with the crane system, then it's probably going to range somewhere between 30 to 40 PSF of steel. I mean, these are the sorts of ratios that it doesn't matter if you're on day one of your tenure with one of our companies, you're going to remember that, and you're going to remember that sort of number for your career. And you're also going to challenge that number. Hey, can we do better? It's just a point of data we should all be considering.
Very good. Very good. I don't see any other questions right now, but like all of these presentations, they will be available for download, and everybody that spoke here I know would be very interested in working with others in the company to help them to do better. And thank you, Omar. Sorry I said your last name wrong before.
No. It's I accept all variations of it.
That's the spirit. All right, very good. And with that,